activity in OSC, the Common Fund Data Ecosystem. It's not a concept clearance, it's for information, but certainly want to hear your thoughts on really what's a matter of stewardship of handling the data for the Common Fund data sets and getting the most scientific value for them.
Can you hear me okay? All right, so welcome. I'm going to talk a little bit about the Common Fund data ecosystem. Kind of ties in with what we just heard from Ananda. So let me state a couple of things here. Firstly, I think we all know that Common Fund has a large number of programs and we generate a ton of resources from those. We just talked a little bit about that. Those resources come in the form of data and analytical tools at different levels of maturity. They're heterogeneous, and there's a lot of them. So one of the things we're going to look at here is how do you actually weave across those? Ananda was talking about a small pilot program. I'm starting to look at the question of what do we do to weave across these programs ourselves so that you can create the right scientific integration points and be able to ask scientific questions. That's the goal of this. But to do this kind of work, you have to have the union of two fields. That is computing and biology. So I'm not going to go through a lot of use cases because I think, as I think Kristen was talking about and a few others as well, you want to have some workshops and you also want to have some collaborations about the use cases you want from here, and I'm not going to claim that I know the best ones of those. Susan Gregorick, who's going to be following me from the ODSS, has some use cases at the beginning that look at the kinds of things we ask across NIH. In the short period of time I have here, I'm going to tell you a little bit about how we're going to try and approach this from a computational background, but keeping in the forefront of our mind the fact that you want to think about this in the context of the use cases.
Okay.
Yep, Jim?
Vivian, we are behind schedule, decided not to present the OAR review today. So your presentation and Susan's they'll engender discussion, I hope, and they are a little complicated. So you have plenty of time.
Oh, okay.
And Susan does too.
Well, let me tell you a story then. Once upon a time, we had lots and lots of databases. So if we have a bit of time, I heard a lot of really good questions around, I'll try and sort of see if we can tie this together from the previous discussion and lead on to what Susan's doing. We all know we've got a complicated situation when it comes to data and the tools that are associated with that. We have a lot of them, and we have a lot of ways that we have to knit these pieces together. The story I'm going to try and tell you is how some of the new technologies that are around here can help us. But technology without that biology involved is just going to be that picture of that swing, right, the engineer gives you that you can't actually use and not useful. But without the engineering and the computing, you can't do the biology at scale. So this is what we're trying to do here with the Common Fund ecosystem. So let's talk a little bit about some of those technologies. So here we're going to talk about NIH and cloud. So I don't know what the level of background is here in folks in terms of cloud, so if I'm going a little basic, bear with me. So the programs that we have at NIH, and this applies to Common Fund programs, but also consistently across NIH, and Susan, again, will speak a little bit more about this. They're either using or planning on using the cloud. And by cloud, I mean generically the usual suspects, which is Google, AWS, which is Amazon, and Microsoft Azure. But there are other flavors of those, but they're primarily the ones that people are using. Why do they do this? Because it's big and getting bigger. GText, I'm going to pick on you, Kristen, is relatively large, 400 plus terabytes, and it's on Google, but we also have other data sets that are even bigger than that. The other reason for doing that is not just storage, it's also the analytics. Often when you do the computing on some form of data, the actual size of the data actually gets bigger as you do the analytics before you get to some derived data. Also, when you run it locally, you can't do some of the analysis that you really want simply because your local computer doesn't have the CPU power to do it. You cannot run it off your laptop like we used to be able to. The other thing that the cloud does is it gives us the ability to share information between geographically distributed groups. And as we have a lot of consortiums, that really enables people to share information. That could be, hey, I ran this analytics and it's sitting in this particular bucket in the directory in AWS. Or it could be, I'm about to run one and we can collaborate together on it in completely different time zones. So that kind of level of collaboration is really what the cloud has enabled us to do. So it's these factors together which are what's pushing us to go towards doing that. The other side of that coin is that the way that each one of these programs is managed on the cloud is quite unique to each program. And there's a couple of points that have to be made there. One, which is often not much attention is paid to the organization of that data, the structure, the access, utility, findability, anything to do with that data. It's basically, I'm doing the project, I'm using the cloud, I'll do whatever my unique project is actually doing and my own special source, which leads to the problem that you cannot share that information easily simply because it becomes very difficult to do it. Sorry, Kristen, I'm picking on you here, but you did raise a good point, which is when you put computing people to do this kind of work, it takes special skill and it takes time. When you create hairballs of data, which is what happens here, I think our affectionate term for that, is to untangle that takes a lot of time, energy, and money. So if we actually spend a bit of time thinking about that ahead of time, we may be able to avoid some of the headaches that we have, and importantly, be able to ask the right scientific questions in a shorter period of time. So the key here is that if you have a reduced ability or complete inability to reuse the data, you either have to regenerate it altogether, or I think, as some people said before, you just leave it. You just take it and then you just go on and just say, I can't use that again. Particularly when you use a postdoc in this situation, because that's what they do. They'll generate the data in tools and they're not reusable. So what are we going to do about that? So as I said before, what we're trying to do with this system is to look at integration points, scientific integration points between Common Fund programs and data. But let's be realistic here. Common Fund datasets interact with other datasets across NIH. And again, Susan Gregorek is going to talk about some of this in her project with ODSS. So the reality of the situation is here is if all of us are using cloud and we're starting to think about how do we think about that we work on these systems together, this may start addressing the issues. That means that we can better organize our data, make it more efficient, and ask some questions across this. That's what the point of this is. Also, the goals of this, some of you have heard about the Data Commons pilot phase. This was an attempt to start looking at ecosystems for data across all of NIH. And so what we're doing here is leveraging some of the work that came from that phase one and putting that within the context of this particular program. I should also say that I'm working very closely with Susan Gregorek from ODSS, again, she'll be speaking directly after me, to figure out how do we leverage those pieces across NIH. That's what her role is. My role is to look at that within Common Fund. So we are trying to create those right bridges. So let me just talk about, again, goals. Making Common Fund datasets more useful and usable within a program and between programs. And this means looking at fairness. I'll reference just a very, one of the outcomes of the Commons pilot was a tool called FairShake developed by Avi Mayan from Mount Sinai. And that work was not defining fairness, but saying based on the current rubrics of fairness that are available in the community, we can do an assessment of your data based on those variety of rubrics. You can choose which one you want to use. And that has really enabled a good conversation to say, well, what does it mean for your data to be fair, and what does that look like? So there's an example of where we took that forward. What we also want to do here is to capture and develop best practices for new programs to leverage. So as we've learnt to move data to the cloud, we've figured out there are use cases between data sets. How do we not reinvent the wheel? Where do we store that and know that as a new program starts, we can ask the question of, well, what have we learned before and how can we use that? We also want to be able to say, how can we enhance being able to ask scientific questions across those data sets? So if you remember what I said at the very beginning of this talk, it's the union of computing and biology. I want to be able to ask a scientific question across those data sets. So what do I need to do for my use cases, and how do I have the computing underneath it to combine those two? Having a scientific use case and a laptop is not going to be able to scale. Having a cloud with no biologist will give me useless science. So I need to create those two across it. So when I say asking scientific questions, it's the union of those two things that allows us to address that. I heard also in the previous conversation the reuse of data in tools. That is complicated. So it's a set of collected things. One of those is fairness. If we can find, access, reuse our tools and data, then that's going to make it easier when we go through to the end of a program to reuse those rather than reinvent the wheel. And I think the other goal here is to incorporate old data into new programs. And I use the term loosely old, but previous programs data into doing that. I think we realize we have legacy. It'll be complicated. And I think a point here is realize time. We need time to be able to untangle some of the pieces from the old data. So overall, what we want to do is create the linking points between science and the computing to be able to address these issues. So what are the activities needed to achieve these goals? Well, we have to onboard data to the cloud in a consistent manner. If I may just ask Council, how many people here know about the STRIDES program? Can I have a show of hands? 1, 2, 3, there's a few. So I won't go into detail. I think Susan's going to cover this as well. STRIDES is an agreement forged between the CIO office, Andrea Norris, and two of the cloud providers, AWS and Google, to get agreements with them to provide NIH with a discount towards storage and computing, because they realize and we realize that we're going to be using those systems. I'll just speak about there. Susan will cover it in more detail. Right now, STRIDES is a billing agreement that allows us to get those discounts from AWS and from Google. So let's say we've done that. The issue becomes that if you move your data in your particular way to the cloud and somebody else does it in a different way, then you've got a disparity problem already. I'm sure most of you, if you've moved files, let me see, you've used Google Drive. You move your files to a folder and one of your family members does the same thing, and they're in different formats, and they label it 1, 2, 3, 4, and the other one is bananas and apples. You have no idea what their data was, and you have to search through millions of files. So if we don't have a consistent manner of doing this, we will create a mess. So I think what we have to do is ensure that we do this in a consistent manner, because right fundamentally, if you don't do this from the beginning, mess multiplied by mess is more mess. The other one is versioning and upkeep of data. All the data sets go through some version of maturity. Initially, in the first sets, you've often got a lot of data coming out, then you've got updates to that data, and as the data sets get more mature, maybe there are smaller updates, but they're still valid. If you only have old data up there that is no more use to the community, or there's a newer one, you have problems in understanding what's there and what can be used. You also want to have a way of cost management and accounting. Even if we have these agreements with Google and AWS and the cost is lower, what does it really cost us? In these initial stages, it's probably going to cost us more than less as we test this out. So we need to be aware of those pieces and put that into play. And we need some documentation for how we plan to use the cloud. And that documentation comes in a couple of different formats. One is for those folks that don't have any background, program officers in particular, who don't necessarily have a background in this, but need to understand what this means, but also other folks in the community that need to understand it from a bio perspective, all the way through to the computational folks. So here's an example of something we've been building over the last 6 to 9 months as part of the Data Commons Phase 1, which is a NIH cloud book. And it starts right from the beginning. What do you have to do? What is the cloud? Why is it useful? How you would use it? And we have it going down. It's not complete yet, but the idea is it would go all the way down, linking directly to AWS, Google, and any other partners that tells you exactly how you will onboard data. So this is a way to have a discussion across NIH about how you consistently onboard data. This work was done in collaboration across ICs, and as Susan will be talking about, we're in collaboration with Susan about leveraging this as well. So a little bit more about activities needed here, drilling down a little bit more. So we'd like to do the following. We want to be able to make sure that the data management plans, the best practices, and the use cases for each program, that we understand what is needed in each of those parts. And here are a collection of things that start addressing at some of the lower level details around what you mean about an ecosystem. So if our overall goal is to look at how we link scientific data, you need to think about, well, how do you actually do that? This is what I'm getting at here. So findability and reuse of data means we need to have some form of standards. Metadata standards are common. What we don't want to do is reinvent the wheel. You want to use what's already available to you. You also want those coming from the community. You don't want those driven by entirely through an NIH governed set. There are plenty of examples where the community is coming towards standards in their own sense, particularly in the genomic field. That's certainly very true, not so true in others. Harmonized data is sometimes a religious war, but it's a very important thing to address. It's hard to do, but but I think we need to look at it because it helps with combined analysis. The cross-cutting data models, what I mean by that is if you have a data set over here and I have a data set over here, you're often wanting to ask questions between those. These models allow us to do that query. So if you have two genomic data sets that you want to query, you have to have some way to do that. That's what the models do. Fair assessment. I referenced this before by Avi Mayan's work done with FairShake. These are tools to improve what fairness means on these data. Can I actually determine that by measuring this? Authentication, authorization. I think the gentleman here was talking about this with the concern for GText. This is, are you you, and are you permitted to use this data set? So in the case of GText, Kristen was saying it's deceased people and it's de-identified, but there are also data sets that have other concerns, they're culturally sensitive, or maybe don't have that. So you need a method to be able to prove that in your system. It's a computational thing to allow you to get access to that information. And it has to be at a high throughput to be able to do it. It has to do it accurately. Data dashboards. This is coming down to how do you monitor what's going on in a program? Frequently what we do on a computational part when we run programs is, where is my data? What does it look like? What level of maturity do I have? Those dashboards are extremely useful for giving you a snapshot of where you are with the project. Those dashboards should also be very useful to folks that aren't necessarily heavily computational. Provides information. We're looking at a Common Fund portal, which is a directory of all the Common Fund data sets. I can hear a question saying, well, other groups are doing this too. So that's the conversation I've been having with Susan and other folks across NIH of, if we have a Common Fund portal, what's the right way for that to connect across to the other ones so we're not just creating yet another silo? Data platforms. A lot of folks are building essentially a platform in the cloud. What does a platform look like? Most of you have used Uber or know of it, or Lyft, or Airbnb. Those are examples of platforms in the cloud. You interact with it as a user, but all the computing that happens on the back end you don't see. If you're using Airbnb, you just care about getting a room and that you don't get an axe murderer at the room and that you get what you need. The platform does the rest of it, but the pieces inside that are really relevant to make sure that we get right. It stops avoiding the silos that we could get. The last one is, if you do all of these or address them, you must have training. People come at it from different levels. You're either a pure bio or a non-bio, or if we have the public who's interested in this, or even a compute person. These are the things that we need to do. We referenced before in terms of workshops. One of the things that we've done in the past, actually HMP, we did this. We had a couple of days with the informatics folks first that worked on the tooling. And the last 2 days, we actually had the bio people that came in and sat with the computing people to work use cases with the bio, with the computing. No one wants to sit through 3 days of Perl, R, or Python if you're a bio. You just care that that system was put in place so that you can then start asking the bio questions. So that's the kind of thing I'm talking about training. Community engagement. None of this works if we simply tell you to do it. It's the collaboration part which is really key, and I think I heard that coming up in the previous conversation as well. And this is about Common Fund programs with PIs and POs working together. Common Fund programs, the POs and the PIs know the data better than me. They'll know all the nuances of the data and understand its utility larger than I will, or the group I'll be working with. Many have existing data programs, and they have, very importantly, a set of scientific use cases which are really relevant to their science. They know it better than we do. They can provide incredibly useful feedback to us around what we're thinking about in this context. And I think these collaborations also are with our cloud service providers. I think Susan will cover some of this too. The cloud service providers, we're talking about storage and compute. But let's face it, AWS and Google also have artificial intelligence and machine learning modules. They're just a few of the additional things that are available to us to use. So what are the collaborations we need to use with these cloud service providers that give us access to some of these tools? What's the right way to use them? What's the wrong way to use them? And what's the right collaboration we need to do? We have to think up the value chain, not just at the raw storage and compute. So what are our next steps? If we've got an ecosystem and we're thinking about the pieces underneath, let me wrap it up. So the next steps would be, we want to do a critical assessment of activities of a small number of Common Fund programs. We're targeting these ones at first. In fact, we've had to reorganize it slightly because of some dates. So we mentioned here MotorPack, Kids First, HMP, and IHMP. I heard HMP came up as an example before, so we will be using it here. We're also going to be working with GText. That we thought was going to happen later, but I think it's going to happen sooner. And what we want to do here is to talk to these folks so that we have a better understanding of the issues within each of those programs. We want to collaborate with them in building some of these dashboards. Some of them have already been built in pieces by the PIs. We want to identify additional needs from these groups of what do we have to do to improve the utility of their data. And then we want to extend the assessment over time to more common fund programs. So we're going to start with 4 or 5, and then we're going to extend it out to 8 or 9. And the idea is to really develop a roadmap rather than build something straight away. Say, okay, where do each of these programs sit in terms of the context of the questions I was asking before? Let's look at consolidating that information, having a discussion of what makes sense to build first, to work with Susan Gregorick and others to figure out what are the right collaborations that we need across the ICs, and then to move forward from there. I assume we'll bring this back to council at some point, and we'll go from there. So the timeline is between April and July. We're going to be doing some of these critical assessments for some of these programs here, again, to obtain this understanding of those programs rather than to assume. Start thinking about what just a dashboard portal will look like. Part of the reason for that is for those folks that come from a pure bio background, portals and dashboards are often easier for these folks to see how things are working. If I look at code, to a biologist, that often doesn't mean much. Whereas I think if we can provide something that's visual, that is meaningful to a bio person, we can have better collaborations. Back to that union between the pieces. So that's what we're going to look forward for July, to create this critical assessment and come up with a report. And then from July to December, we'll be looking at the additional data sets and looking at how we translate activities from those reports out. Again, I'll be working with Susan around some of this as we team up on that. Additional to this is the team that's going to be working on this. This was, for those who are aware of this, is the Data Commons Phase 1, which is what we infer here by DC PPC. That's what that acronym is. Some of the awardees' work was rescoped to do this work, so essentially the next phase. And so that includes Owen White, Avi Mayan, who I referenced before, Carl Kesselman, and a few others, but the funding's pending on that, so I can't release that. The Common Fund team is shown here. And I'll leave it at that for questions. I think I'm at 15 minutes. I hope that was okay, Jim.
Okay, thank you, Vivien. Are there questions
Thank you.
about what we're trying to accomplish here and suggestions or ideas?
Yeah.
This sounds really good. So the question is, we were just told that nobody's using the data, and now we're going to have some great infrastructure for data that isn't being used. But I think that with this kind of infrastructure, the data will be more accessible, and there's actually training on the backside and advertising. Wouldn't this be what we want to do, rather than do we need to do both of these things? This sounds like a really potentially good thing to do.
I think the intent is to try and merge the two. I don't know if Jim or Betsy want to contribute to any answers. I think it would be...
Well, I'm hearing this as a really important structural step that precedes the other work. So I think if you're putting out a proposal tomorrow, has to get written, approved, et cetera, while they're working through this, I think it dovetails okay.
I'm just still skeptical about, Andrew and I had a little discussion, and it's a one lab thing as opposed to a big infrastructure thing. I'm just not convinced about the first one, but this one, you know, despite all the problems, has a lot of potential.
So I'd say the first one, the goal of that is to show some integrative biology, and you don't need this infrastructure to do that, right? And if nobody can come up with any fundable proposals to do that, then that might argue that there's... Right, of course they will. If there's funds, they will. But that can be done, and they're short and they're fast. And this is bigger, and the open question is, although it's a great idea, the question is, will we get it right? If we build something, will they actually come? And I'm going to turn that around to Vivien and ask my usual question, which is, this is lovely idea and everything, but it's a silo, as we know. It's the common fund silo. And what I can tell you my users want, because we hosted a survey of users to GTEx portal and asked them what they want. And without question, 90% of them want to integrate data sets that exist, these big data sets, and they're across the NIH programs. And this is just one. So really, this centerpiece needs to be across all of these, as opposed to multi-silos, or you've done nothing that any of the scientists will want. So
I agree with you.
I know you do.
I think you're referencing the cylinders of excellence, right? Or silos. Let me take the first question you asked, how do the two combine? Well, I think a really good thing that came up from the previous discussion was a workshop which is going to identify use cases. And this is some of the technology back-end pieces that we need. First of all, I'm not trying to build a monolith. I'm just trying to test some things out. So when you run these two things in conjunction, the work that was presented by Ananda could be a way to capture better use cases across and between data sets, which is essential. And it could be combined with this. So that's one answer to that, which I think would be important to do. To Kristen's question about the cylinders of excellence. Yes. So I have the same problem. The problem is if you try and do everything, you do nothing. If you don't do enough, what's enough? So I'd say here in the terms of Common Fund, I'm going to try and cross all of Common Fund data sets, but with the very beginning thinking two things. Susan's looking at trans-NIH efforts, and I'm also actively working with other ICs around, okay, you may be interested in using a Common Fund data set. You've already got a system. What's the right way to have that discussion with you and interaction? Does it mean I'm going to solve the silo problem? No, but it's the right conversation to have. And it means two things. Being able to technically interact with those groups, and I'm thinking right now of NHLBI, NCI, and NHGRI. And it also, another thing is the social interaction. What I've learned out of phase one from what we were doing last year is sometimes the technology is not the problem. It's actually the social interactions. It's getting people to understand when they come from bio and computing and together, and also understanding that they are actually building a silo. One of the biggest problems I've had is I talk to someone, they say, I've solved it. Why are you not doing this? I'm like, well, because you've actually built a silo and you're asking me to use yours. And they can't even understand that they've actually built a silo. So I think the conversations we have to have are about, put it in the forefront of our mind, have that continuous conversation and ensure that we reach out across to our ICs to do this. And I think we've got the beginning of that through the ones that I mentioned and also in the work that we're doing with Susan.
Kristen, I want to add another perspective to that in terms of long-term strategies for how we get there. One of our limitations is that all of these data sets and programs are funded for the program. So that we can't have them take a time out and go sit in the corner for 3 years until we come up with NIH-wide solutions. So we have multiple goals on, shots on goal going on here, even within the Common Fund, but we're talking to each other. And I think we're in a period of evolution where we're trying to get there, but it involves a lot of people and a lot of programs, and it's just going to evolve.
Any other questions?
Yeah, I heard at NCATS Council yesterday, they were talking about the cloud that they're about to use or will use. Is there any chance this is all the same?
99.9999%.
Okay, I just assumed that it would be, but I just wanted to check. Okay.
Yeah. So what would be good there is what I mentioned before is if we all agree to a set of best practices to onboarding cloud, I don't need to, if NCATS was to work with us, great, that would be ideal. They could then provide really good input about how we all do that together. That cloud document I showed up there, that's a great place for us to collaborate on.
Just had a question about long-term access to data. Perhaps it's considered in reuse, but maybe I think it's worth re-emphasizing. In essence, how do you ensure 20 years or 30 years of access to data with 5 years of funding?
Well, let me see if I can I'm not sure I understand your question. Is it from a PI's perspective?
Well, yes.
So I got
know,
5 years of funding, but the data could be up there for 20.
Yeah, and the NIH has faced a lot of challenges in providing long-term funding for a whole number of databases, and it's been a significant sustainability issue. And
So one of
does the cloud, do these agreements with Amazon or with Google provide any provisions for long-term access?
No, but that's what the Common Fund data ecosystem is looking at. So let me address that specifically rather than give you an acronym. You've got 5 years of funding, but you could expect it to be on the cloud for 20 years. One of the things that we leveraged from phase one in the Commons was learning that our data stewards, the people who are the stewards of the data, are the ones that know best about this. So maybe we need to think about ways, as we mature data and have a look at it, what's the role that these people play after the 5 years of funding? Right now it's like, do this project and then it's finished. But what's the sustainability of that data? Is there a way to find a way to support these folks in the appropriate way when it's scientifically relevant? So a couple of things I could imagine would be the following. You have a data set that after 5 years is still really hot, okay? You need to maintain it. So there's version control issues. There may be some things that you do with derived data. That's something that we need to figure out how to fund. Say in those 5 years you find out that Common Fund Program number 1 and Common Fund Program number 2 really should intersect. That's another way that you want to support that. A third one might be the data is still valuable but not used as much. What you then do is still make it available on the cloud, but you move it from hot storage, which is very expensive, into the cooler storage, which is cheaper. So it's still available, but it's at a lower cost storage, and it takes a little while to pull back, but still available to you. These are all the considerations. Does that help answer the question?
Yeah, I think those are great. I just want to make sure that in these various frameworks, these are key issues that are being considered.
Yeah, I'm definitely thinking about all of those, including some of the technical back end. For example, we are working with cloud providers, but what I don't want to do is be beholden by them. So how do we ensure that if in 5 years' time they say, suddenly there's a giant increase in the cost, how do I know how I manage that? So one of the additional things, it's not mentioned here, but I've been certainly thinking about it, is hybrid clouds. These are groups, Broad has one, for example. They run their own vast CPU base in their own organization that have turned that into a mini cloud, so to speak. There are many things that we can test on those environments that are not on commercial clouds that also inform us about what our cloud providers are doing. So we should leverage that to inform us in the future of what technologies we should be aware and better manage what those relationships might be with the cloud providers. We want to be on equal footing, not with them that far ahead of us, which is where we have been up until now.
Yeah, Paul, let me add, just want to repeat what Vivien said. We're in a period of evolution. We don't know what data to store, what has value, how much to pay for it, how much to keep. We have a policy of how long you're supposed to keep your lab notebook before you can throw it out, but all this, we're out in an explosion of digital data. We want to have approaches to what to keep, where to keep it, who pays for it, what are the criteria for keeping it. It's very difficult. It's going to be fun to watch this for the next 10 years.
So I'll just say that's not just an NIH issue. Obviously, each of our institutions is struggling with exactly that. And we're also struggling with wondering what's going to be expected of us and then who's going to pay for it, right? Because a lot of this is a collaborative effort between the funder and the fundee, especially when the fundee is no longer funded.
Right, and you also don't want the cloud provider to be in there creating a problem.
Well, there's a huge, again, from our own institution, we are thinking a lot about use of the cloud, but have some of those concerns about what's it going to be like in 10 years, and if we've lost our internal ability to store data, and we've, become very dependent.
I also didn't talk about it here, but data governance and policy and usage is critical. I didn't have time to cover it, but it is an absolutely essential part of this, because one of the things I would like to do in the system is to test it with data that, if it does leak, it doesn't cause too many problems. to pressure test it, so to speak. But we're going to be dealing with a lot of human subjects data, so we have to be aware of that. So what are our policies and procedures? And we're now dealing with third party, which are the cloud providers. So if we're going to be in that triangle, we need to understand their business model. They need to understand, quote, unquote, business model, and they're very different. A business is a business, NIH is an organisation, and the two don't always meet in the middle. So I think those are the other things that we need to definitely get some input on and address.
So would the council like to hear from Vivien, let's say in January, on how this effort is going? Let's do that. Okay. Vivien, thanks a lot, unless there were other comments. Okay, thank you. So we'll move on to our last presentation. I want to thank Maureen for her flexibility today. I'm sorry we got behind. Okay.